Alrighty, so let's continue. So example C is just that continuation where we are going to be doing the same thing. We're given information, we're filling it in on the side, and we're graphing it. Alright, so the parent function is f of x equals the square root of x. Right, we're translating it left 5 and down 1. Right, this is your description. You are doing a horizontal, right, shift left 5 and a vertical shift down 1. Okay, so if we have that function notation in the equation, right, if we were to actually write this out, we're using the square root. So our f of, right, x, and I say, okay, shift is plus or minus, right? Left would normally be negative 5, right? But the x's used the opposite sign, so it would be plus 5 in that function notation. And then the vertical is just on the outside, right? Down 1 is in that negative direction, so we subtract 1 on the function notation. Alright, the equation's the same thing, right? We have that square root, so that is the symbol or operation we use. The x plus 5 is still on the inside, the minus 1 is still on the outside. Okay? Alrighty, so that would be all of our information, so let's go ahead and graph it now. Right, so x comma y, our square roots are 0, 1, and 4, and 0, 1, and 2 for those points. Alright, so the horizontal shift to the left 5, that would be subtracting 5 on the x's. Down 1 is subtracting 1 on the y's. So we have 0 minus 1, 1 minus 1, and a 2 minus 1. And then 0 minus 5, 1 minus 5, and 4 minus 5. Okay, and from there we graph it. So negative 5 comma negative 1. Alright, negative 4 comma 0. And then negative 1 comma 1. Alright, now remember, your square roots are those half seagull kind of shapes. So we start going up. No, it's not quite what I wanted. Okay. More or less, it'd be following that direction, right? It'd be slowly going up. We have a bit of that curve. Life would be great. Not the best curve I have going there, but it's slight. It's there. Okay? So that would be more or less the basics of graphing, right? So let's continue on. So now we have some more of our little crazy graphs, right? These are not parent functions, but we can still graph them regardless, right? So what I would do is, for the shifts, you really don't need to make a table for these ones, but if you want to, you can, right? So x comma y, your first point's at negative 3 comma 1, next point's at negative 1 comma 3, next one is 1 comma 3, last one is at 2 comma 1. Right? Then you'll notice we have x plus 1, so we are subtracting 1 on the x's, and then that minus 2 means we're going down 2 on the y, so we should be at negative 4, negative 2, 0, and 1, negative 1, 1, 1, and negative 1. So we have negative 4 comma negative 1, negative 2 comma 1, alright, 0 comma 1, and then 1 comma negative 1. Right? We should have the exact same shape as before. The only difference is that now we have there we go. And now it's just been moved. Okay? With stretches, you'll actually be changing what the shape looks like. Translations just like picks it up and places it somewhere else. We should expect the exact same shape. Alright, let's do one more of these. So we have g of x equals f of x minus 2 minus 4. So all we're doing is we're taking those same points that we see before, we're picking them up, and we're moving them. So it's x comma y. Alright, and the first point I see is a negative 2 comma 4. Alright, the next one is a 0 comma 2. And the next one after that would be a 1 comma 3. Last but not least, 2 comma 1. Alright, with the x's we see an x minus 2, which means we are doing the opposite of what we see. We're adding 2 to those x's. The y's, we do literally what we see. Right? So we have 0, -2, -1, and -3. And then we have 0, 2, 3, and 4. Take your two outermost columns. Alright, and then from there, so we have 0, 0. Okay, we have 2, -2, 3, -1, 4, -3. And then you connect the dots. Alright. Alright, so that is the basics of graphing stuff without parent functions, right? With translations, you can literally say, okay, with this point, right? You'd say, okay, we're going to the right 2 and down 4. Okay, same thing, right 2, down 4, right 2, down 4, right 2, down 4, right? You could do it in little pieces like that. You wouldn't have to make the table if you don't need to, right? For stretches, I'd recommend it. For shifts, if you want to. Alrighty. Last but not least, we have given the graph or description, write an equation for the transformation. So, let f of x equals the square root of x, and if g of x is the graph of f of x shifted down 2 and to left 1, write the equation for g of x. So it's the stuff we've already done before, right? We have the description. Now all we need to do is we need to figure out what that looks like in this equation. So we're using the square root. So we're going to have a square root in our answer, right? We are shifting down 2. Down 2 is vertical. Vertical's on the outside. We do exactly as we see, so we're going to be going down 2 or subtracting 2 at the end. And then we see left 1. Well, left 1 is subtracting 1, right? But left is your horizontal, which is your x's, and the opposite of negatives is positives. So we have x plus 1. And that would be your equation. Alright, so on your homework, be careful. If it says write the equation and it doesn't have like the g of x or y equals, right, make sure you put the y equals in there. Okay, make sure it is a y equals. Most equations do require the y equals, not necessarily the g of x. Okay, if it's going to be one or the other. That much is a guarantee. Alrighty, so keep an eye out for that. So that was literally the answer. That's all you need to do for that one. Alright, the other way we can write equations is if we have the actual graph. Now what I'd recommend for these ones, I'd say, okay, normally your parent graph, right, we have that -1, 1, the 0, 0, and the 1, 1 point, right, and then it goes up, right? So I'd say, okay, the most notable point for me when I'm graphing these, right, the most notable point I see would be the 0, 0 point. Right, that's the easiest one to find. So I'd say, okay, well, where did that 0, 0 point go? Where did we transform it to? Well, you'll notice that here we went down 1 and to the right 3. Okay, and that's all you need. Now, on the graphs, I would not give you or expect you to necessarily find a vertical or horizontal stretches, right? That multiplication necessarily from a graph. That's kind of really hard to spot. So just assume that if you see a graph, you're probably only seeing the transformations of shifts, okay? Or reflections. Reflections are also free game. All right, so. And the only exception is if I actually gave you a description and said that you had stretches. So from the graph, assume it's probably only stretches, maybe reflections. Okay, from the equation or description, stretches are free game. Alright, continuing on. So first thing I look for is I say, great, well, what kind of graph do we have, right? What's our parent function here? That's an x squared. So if we're writing the equation off of here, we should be seeing the square in there. Because we have horizontal movement, we know we're going to have x plus or minus something, right? Well, it's got to be 3 because the only movement we did horizontally was to the right 3, or in other words, in the positive direction 3. Remember, horizontal is the opposite operation, so we have x minus 3 in our equation. Alright, last but not least, right, we look at that vertical movement. We went down by 1. We do exactly like we see, vertical's on the outside of the equation. And so we have y equals the x minus 3 quantity squared minus 1 as our answer. Alright, and that's it for shifts. That's the basics, and as crazy as it gets when you have just shifts going on. Alright, thanks for watching.